Hi there, I'm Buono. A look at the gadgets I've built today. I'm going to run through some of the things I've made over the years. I hope it gives you a feel for what you can build and how it comes together. So, first up, this one. Any idea what it is? It's modeled on an elephant, more or less. That's the shape I was going for. But it isn't just an ornament, a gadget for watching over your kids. There's a microphone hidden inside this red panel here. The built-in mic picks up your child's voice, and here's how you use it. At home, it normally just sits there in this elephant shape. Your child talks and chats with it, and that's how it learns to recognize their voice. Voice analysis is done with Chainer. It runs the voice through an open-source library called Chainer to analyze it. It learns your child's voice once, and after that, the body and the head come apart, like this. They're held together by magnets too. So you take the head off and clip it onto your child's clothes. It attaches like a badge. Kids sing to themselves a lot when they're on their own, or they cry, so there's plenty of voice for it to pick up. Or they call out for mom or dad when they're feeling anxious. It picks up your child's voice from a distance. The audio it captures is sent out over the Soracom Air cellular link. Then Empath's API works out the emotion in the voice. So that's what it does. Let me give you a quick tour of what's inside it. The shell is 3D printed. You can probably make out the print layers running across it. This angle shows it best, I think. I got the layer direction wrong when I printed it, unfortunately. The back ended up looking a bit odd, and the front too. See here. I really regret getting the layers wrong. I just didn't have time to reprint it. The microcontroller board is a Raspberry Pi Zero. It runs off a 400 mAh lithium-ion battery. It also packs in a combined battery monitor and DC-DC converter board. On top of that, there's a relay board in there, and the microphone I mentioned, and that's everything that goes inside. And this part down here is simply the speaker unit. Because it's meant to chat with your child at home, there's a speaker built into it. You can see inside here. Can you make it out? I also made a short intro video for it, so do take a look if you're curious. I've put a link to the intro video in the description. That's the kind of thing I get up to. Right, next one. This is 3D printed as well. I doubt anyone can tell what it is at a glance. Believe it or not, it's an ice cube. Ice cube shaped. Probably a world first. A world first? An ice cube gadget. There's a lid on the top of it. It has a color sensor built into the inside. Cocktails have all sorts of colors to them, don't they? That's the point. Drop the gadget into a glass of cocktail, so you drop it straight into the cocktail. First, it detects the color of the drink, and then it passes that over to your phone. It reads the color and sends it to your phone over Bluetooth. The phone is already paired with Hue. It lights the room in the cocktail's color, so it's a gadget aimed at grown-ups, I suppose. Right then. This one was 3D printed as well. The hardest part was making the underside. You can just see inside it, and the color sensor sits in there. So if the base is too thick a base, and it can't read the color, I had to make the base as thin as I possibly could. And getting that surface right was really hard work. Right, on to the next one. This is just a simple board I made for trying things out. A board for trying things out. It breaks out micro, USB, and headphone jack signals. Every one of them is brought out to its own pin, which makes the signals easy to probe and work with. Circuit and layout designed in KiCad, a free PCB tool. This one is purely a test circuit, so the circuit itself doesn't really do anything. This was the first board I cut on a PCB milling machine. I made it on the SRM20 at Tech Shop Tokyo. The machine I always use learn PCB milling, and it really widens what you can build. It's a bit tricky to get the hang of, but it's well worth trying. Right, next one. A gadget that plugs into your phone. Inside the case, there's a board like this. My first project working with a startup, I handled the board design for it. The idea behind it is simple. It draws power from the phone's headphone jack and lights an LED. There are only 7 components on it. The hard part was that it had to be really small, so I packed everything in as tightly as I could. Right, moving on. Next up are these ones here. These two belong to that ice cube gadget I showed you earlier, the one I've been calling the cocktail cube. A coin cell holder and relay board for the cocktail cube, I designed these in KiCad as well. Board designed in KiCad. This next one is a fairly specialized bit of kit, a pulse transformer board for driving a FET. I designed this in KiCad and had the board made. Board designed in KiCad. When I make boards myself, they're usually blue. I just like blue, so I go with blue. This one's white though. A frequency to voltage converter board. The part used here is a JRC NJM4151. The circuit is straight out of the datasheet, so there's nothing clever about it, but this is the kind of thing I put together. And this next one is simply a bare board. And then we come to this one here. Can you tell what this one is? Probably not, just from the look of it. A shield for the Arduino DUE. This one is actually a study board for simplified MBD. MBD stands for model-based design. A long story, really put simply, it's a newer development process aimed at making design studies and evaluation far more efficient. There's plenty written about it, so look it up if you're interested. Setting up an MBD environment normally costs a fair bit. Made by following a Koronisha book on a low-cost MBD workflow, and the book has a schematic showing how to build the board. So I laid it out and had it made and soldered every part of myself. Sadly, it isn't working yet, and I'm still tracking down why. Once it runs properly, I really want to put it to use. So that's everything. I've built a fair few things over the years, and whether I'm using a 3D printer, or working in mechanical CAD, or doing board design in ECAD, or laying out the copper traces, every stage of electronics is a joy. There's something enjoyable in every one of those steps, and watching it slowly take shape is what makes it fun. That's why I can't give up electronics. So I'm still far from skilled at any of this, but I want to keep building and keep getting better. So let's all keep at it together. That's it for today. Please do subscribe. Requests, leave them in the comments and I'll cover them in a future video. So please do write in. Thanks for watching.